Hi, this is Mr. Bowman, and I want to show you this example of function analysis. We've been given a function graph to look at. It's here on the left, and we want to determine the domain and the range. We want to determine on what intervals the function increases and decreases. We want to know if it's constant anywhere. We want to know the maxima and minima, and we want to know if the function is even, odd, or neither. So let's start with the domain. The domain is the set of all of the x values, all of the inputs. Well, this function goes on forever and ever, and we know from looking at function graphs that the end of the graph here is only the end of the part that we can see. This function doesn't stop at x equals 4, it keeps going and going and going and going. In fact, it goes on forever. Now, we'll never try to deceive you by giving you only a part of a graph that doesn't show you what the rest of the graph does. So this graph will go on forever and ever. Every x is in this between -3 and 4, but even beyond in both directions as well. So the domain here is all real numbers, and I hope you remember from Algebra 2, then interval notation, we write the set of all real numbers from -infinity to infinity. What's the range? The range is the set of y values. So I can see that every y value on the graph from -6 to +6 is in there somewhere. And again, if I understand that this graph continues on forever in both directions, I think I can say that the range is all real numbers as well. Okay, where is the function increasing? I find it really helpful to think about tracing the graph with your finger or with a pencil from left to right. So if I think about starting here at the bottom of the graph that I can see, as I'm tracing the curve here, the y values are becoming more positive. And where does that stop at? It stops right here. And here's a very important thing. I want to tell you where the function is increasing by telling you the x values where it's increasing. So it's increasing from all of these x's until this one right here, which is -1. From here until here, now I think about tracing the curve again from left to right, and now my pencil's going down. My values are getting less positive, they're becoming more negative. And then it happens all the way until this point here at 2. And then I will finish the curve here, and now I'm increasing again, and will forever and ever and ever. So what I'm doing when I'm increasing is I'm increasing from all of the x values, even off the graph, until this one. I didn't increase from this x value to this x value. And then from this x value on forever, I'm increasing again. So that's an interval that has two parts to it that will connect with that union u. We're increasing from these x's, -infinity to -1. And then I'm going to say union with this set. We're also increasing from 2 to +infinity. By far the most common student mistake on increasing and decreasing is that they'll give as answers a set of y values. Like they'll say this function is increasing from -infinity to 1, and then they'll write union increasing from -3 1/3 to infinity, and I can totally understand why someone might write that. But when I ask you about increasing and decreasing, I want to know what x values is that happening at. If you get the increasing interval right, usually it's pretty easy to get the decreasing interval. Where is this thing decreasing? Well, from the x value at -1 until we get to an x value of 2. That's the interval from -1 to 2. Now, something that's worth pointing out here is that you might have thought to use the squared off bracket to say that we are including those values for increasing and decreasing. And frankly, in AP Calc, they would probably give you credit for that. When you take AP Calc, I can tell you a little bit more about why I don't usually include those. So I think the best practice here is to not use the inclusive interval notation brackets for increasing, decreasing. Okay, is this function constant anywhere? Is there any place where as we move from left to right, the y values aren't changing? We're talking for more than just an instant, right? If you pick any single point on the graph, you can say that there's no increase on that interval. We're talking about over an interval, a change of x's. And there's not. There are none. If you would rather instead use the empty set symbol, Almost looks like a little circle with a slash through it. That's fine too. We're looking now for the maxima and the minima, and we said these are like the peak and valley points. So the maximum points would be any point where the function switches from increasing to decreasing. And I can see that on the graph right here. That point, a maximum point, is a whole point, x and y, is the point -1, 1.167. There could be more than one of those. You could have a graph that has 2 or 3 or maybe infinitely many maximum points. Are there any minimum points where we switch from decreasing to increasing? Yes, right here. At 2, -3 1/3. Not every graph will have a maximum and minimum point. Okay, the last thing we want to ask is this even, odd, or neither? An even function would have y-axis symmetry. You could fold the graph right down the y-axis and have perfect halves on each side. That's not this case. An odd graph, you could flip 180 degrees around and it will look exactly the same as it did before you moved it. Now, I can't do that here on the screen, but you can on your paper. Try that real quick. Does that graph look exactly the same, like same exact points? No, it doesn't. So this is one of the many functions that is neither even nor odd. This is neither one. Okay, this one is for you to try, and what I'd like you to do is to pause this video, see if you can determine the information about the graph you're given, use the paper you're given to follow along and work off of. And when you think you've got it sorted out, hit play and we'll get you some feedback. How'd you do? Well, let's take a look at this thing. This is a function whose domain, I believe, we would say is all real numbers. I don't see any evidence of any x being missing here. I know that the graph continues off the graph in both directions, and those x's that aren't in the graph will be caught as well. So the domain of this one is all real numbers, everything. I don't think the range is, though, because I know that this graph will continue off the edge of the graph here, increasing in this fashion, in almost a linear fashion here. And I know that the x's before -6 will have bigger positive y's than the one we've got. I think this one has like a smallest or a least y value. And I think it's right here at -3. That appears to be the lowest that this graph ever gets. Now I think it will get the negative y values between -3 and 0, and I think it will get all of the positive y values. So I think the range is everything that includes or is greater than -3. We write that in interval notation as from -3, including the -3, to positive infinity. Okay, where is this thing increasing? So if I think about tracing the graph from left to right, I'm not increasing now, but right here at -2, I will start increasing, won't I? And I think I'll stop right there. So part of my answer for where I'm increasing is that I'm increasing from -2 to 0. Starting at 0, though, I'm decreasing. I'm decreasing until I get here to x equals 2. And now from 2 and everything on, I'm increasing again. So I want to write that I'm increasing from -2 to 0 and union u from 2 forever to infinity. Where am I decreasing? Well, I was decreasing at the start of it from -infinity down to -2. Increasing. Oh, also I'm decreasing from 0 to 2. The x value 0 to the x value 2. And I believe that takes care of it. I don't think I'm constant anywhere here. Do I have any maximum or minimum points? I have a maximum point right here, where I switched from increasing to decreasing, and that ordered pair would be 0, -1. And I think that's the only maximum point I've got. I don't really have a maximum point here off the right edge of the graph because as I know the graph will continue forever. And I don't have one over here as well. I do think I have not one but two minimum points. I see a point here where I switch from decreasing to increasing at -2, -3. And I have another one here at 2, -3. Picky but important point, don't put a union U there. We're not, if you put the union symbol to connect those two, you're telling me that we're talking about intervals now. We're not, we're talking about ordered pairs. So just list them, and if there's more than one, put a comma. Is this even, odd, or neither? Yeah, this is even. If you fold this graph right down the y-axis, you would have each half of the graph fall directly on top of one another. So this is an even function. Alright, same deal. This one's for you to try. Hit pause, see if you can sort it out, and when you think you've got it worked out, hit play to get some feedback. This one is a little more complicated, I think, because this is a piecewise function. This is not a nice continuous function. But we'll sort it out. We'll get it taken care of. What's the domain? Is every x in this graph? All of the x's less than -1 are on this linear part of the graph. And -1 itself is in the graph with the filled in dot here. The x's that come directly after -1, even those that are less than 0, are in the horizontal line segment of this graph, up to 2. I don't see anything between 2 and 3, and I don't see anything that actually includes 3. But I see everything after x equals 3. So what I think I need to say for the domain is that it includes everything up to and including 2. And including 2 is with the bracket, isn't it? And then in union with also the set not including 3, but all the stuff after 3, from 3 to infinity. What's the range? The lowest value I see anything is around y equals -3. And I don't actually see a point at -3 because this point is an open dot. We're saying that right after that point we're including things, but not that point itself. And just with this part of the graph, I see the idea that the y's will continue on and on and on forever. So I think I'm going to get all the y's that are greater than -3, just not -3 itself. Where is this thing increasing? From left to right, we're not increasing at all on this section of the graph. And even though I had to jump up and get to this linear section, we didn't have an increasing function there because the function never, made an increase. It just instantly went to that value. I think the only place I've got increasing behavior at all is on this section, and that's from the x value of 3 on forever. So we're increasing from x equals 3 to infinity. Where are we decreasing? It's this part. The x values for that part are from -infinity to -1. And we are constant on an interval. This part. On this part of the graph, the y values aren't changing at all as x increases. So that's from -1 to 2, not including -1 and including 2. Are there any maximum points? No. There are no points where you switch while being continuous without jumping from increasing to decreasing. And are there any minimum points? Are there any minimum points where without jumping from one part of the graph to the other where we're at a lowest point? This point looks convincing, but all we did to switch from here to here. In fact, we didn't switch from decreasing to increasing here. We switched from decreasing to constant. It doesn't really fit the definition. This graph has no minimum points either. And is this even, odd, or neither? It's neither one.